Hello friends, I Dr. Sonendra Kumar Gupta, Professor Engineering Mathematics Department, Department of Basic Science. Now today we are discuss about the definite integral limit of sum. Now first of all discuss about the definition of the definite integral limit of sum. If f of x be any bounded and continuous integral function in the closed interval ab, then the integral a to b f of x dx equal to limit x tend to 0 h f of a plus h f of a plus 2h up to f of a plus n minus 1 h, where h equal to b minus a upon of n, or we can say that nh equal to b minus of a. When we solve the definite integral limit of some question, we need some important formulae. Now here we discuss about some important formulae. Number 1 plus 1 plus 1 up to the n time, that means n. 1 plus 2 plus 3 up to n times, that is called the summation of n, which is equal to the n plus 1 upon of 2. Number 3, 1 square plus 2 square up to 3 square up to n square times, that means summation of n square, which means that n plus 1 2n plus 1 upon of 6. Fourth, 1 cube 2 cube 3 cube plus n cube times, that means summation of n cube, which means that n plus 1 upon of 2 ka whole square. Next, sin alpha plus beta sin alpha plus 2 beta sin alpha plus n minus 1 beta, which is equal to the sin alpha plus n minus 1 to beta into sin n beta by 2 into sin beta by of 2. Cos alpha plus cos alpha plus beta cos alpha plus 2 beta up to cos alpha plus n minus 1 beta, which is equal to cos alpha plus n minus 1 2 of beta sin n beta by 2 into sin beta by 2. Similarly, we have some important formula regarding the arithmetic progression of the geometric series. Now the seventh formula is ar square up to ar to the power n minus 1, which is equal to ar to the power n minus 1 upon of r minus 1 when r is greater than 1. Now second formula, a 1 minus r to the power n upon of 1 minus r, then r is less than 1. And the eighth formula, limit x tend to 0 sin x upon of x equal to 1, limit x tend to 0 cos x equal to 1, and limit x tend to 0 tan x upon of x equal to 1. And the last, limit x tend to 0 e to the power x minus 1 upon of x equal to 1, limit x tend to 0 a to the power x minus 1 upon of x equal to of log base ea. Now the first question is, evaluate integral a to b x dx by definite integral limit of sum is equal to, suppose first of all this function is x is called the f of x, so we can write f of x equal to of x, and we have the limit a to b, it means nh equal to b minus of a. Then we know that by the definition of definite integral limit of sum, we have integral a to b f of x dx equal to of this much. Now f of x equal to of x, it means that f of a equal to of a, f of a plus h equal to f of a plus h, f of a plus 2h equal to f of a plus 2 of h, and similarly f of a plus n minus 1 h equal to of f of similarly f of a plus n minus h equal to of a plus n minus 1 h. Now limit x tend to 0. Now we're putting the value of f of a, which is the a, f of a plus h equal to f of a plus h, f of a plus 2h equal to f of a plus 2h, or a plus n minus 1 equal to a plus n minus 1 h. Now we have a are we can separate, that means like this much, and similarly we can take the common h in these terms, that means h in bracket 1 plus 2 plus up to n minus 1. That means we can say that a in bracket 1 plus 1 plus 1 up to n times, and h 1 plus 2 plus 3 up to of n minus 1 time. And we know that if we add the 1 up to n time, then we get the n. Similarly, if we add the 1 plus 2 plus 3 up to n minus 1 time, then we can use the formula summation n equal to n plus 1 upon of 2. Here n equal to of n minus 1. Why? Because here we would write the term for n minus 1 times. So we can that h na plus h nn minus 1 upon of 2. Now we can multiply the h in the terms of this and this, so we can get nha nh minus h nh upon of 2. Now we have nh equal to b minus of a, then we can put the value of nh, which is the b minus of a. Now here we see that b minus a is common, so we can take the common b minus of a, then we get b minus of a, then a b minus of a, and the value of h is 0, that means minus 0 upon of 2. Now we solve this term, that means we have b plus a upon of 2, which is the b minus a into b plus a upon of 2, that means b square minus of a square. Now our second question is, Evaluate integral a to b x square dx by the definite integral and limit of sum. So here f of x equal to x square, it means that f of x equal to x square and nh equal to b minus a. Then by the definition of the definite integral limit of sum, we have integral a to b f of x dx equal to of this much, and here f of a, that means a square, then a f of a plus h, that means a plus h whole square, and similarly and so on. So we can write the above term in this way, that means a square a plus h whole square a plus 2h whole square up to a plus n minus 1 whole square. Now we expand the value a plus h whole square a plus 2h whole square or a plus n minus 1 whole square in this way. That means a plus h whole square, it means a square plus h square plus 2ah, and then a plus 2h ka whole square, it means a square 2 square h square 4ah, and the a plus n minus 1 whole h square equal to a square plus n minus 1 whole square h square 2a plus n minus 1 of a h. Now we can take the common of a square of from the each term, and similarly the h square from the each term, and the 4 2ah from the each term. Okay, so we can say that a square 1 plus 1 plus 2 up to m times, that means h square 1 square 2 square 2 n minus 1 whole square 2h, and so we can write this much. Now this a plus a up to n times, that means of n 1 square 2 square 2 n minus 1, that we can apply the formula of summation of n square, which is equal to n plus 1 to n plus 1 upon of 6, and we put the value of n in place of n minus 1. So we can say that now you have put the n equal to n minus of 1 and n equal to of n minus of 1. Okay, so we can get n a square plus h square n minus 1 h 2n minus 1 upon of 6 2h 2ah and n minus 1 upon of 2. Now we can multiply this h in the each term. Okay, so we can get nh a square nh minus h nh, then 2 nh minus h upon of 6 2a nh minus h nh. Now this 2 is cancelled out. Now we have nh equal to b minus a, then we can put nh equal to b minus of a. Now b minus a, that means b minus a minus h, b minus a 2b minus minus h, and 2 b minus a minus h, and b minus of a. Now we can common from b minus a from the first second and last term, so we can get b minus a limit s tend to 0 a square b minus of this much. Now put it the limit h here, that we can get b minus a square b minus a minus 0 to b minus of this much. Here we see that now this 2 is cancelled by this term, so we can get b minus a square b minus a whole square upon 3 b minus. So now we can multiply this 3 in this 2 term, or and expand the b minus a whole square, so we get 3a square plus b square plus a square, and so on. Now this 3a square is cancelled out, then we have b square plus a square plus ab, and we know that b minus a b square plus a square plus ab of ab, which is equal to b is bq minus of aq. So we have the required result integral a to b x square dx equal to bq minus aq upon of 3. Okay, now the third question is evaluate integral 0 to 5 x plus 1 dx by the definite integral and limit of sum. So here the function is f of x equal to of x plus 1, and the value of a is 0 and the value of b is 5. So we can that nh equal to 5 minus of 0, that means a 5. Now by the definition of definite integral limit of sum, we have this much. Now each value of a here 0, so we can put the value of a is 0, and we can write in this much. Now f of 0 equal to, that means a 0 plus 1, that means a 0. F of h equal to, that means h plus 1. F of 2h equal to 2h plus 1. In this way, now we take the common, now we take the one value, say the common 1 this much, and we take the common value of h from this term. So we can write in this way 1 plus 2 plus n minus 1 1 plus 2 plus n minus 1, and we can write again n minus 1 n upon of 2, and 1 plus up to n time, then that means we can say in this way. Now we can multiply the h in the each term, so we get this way. Now we multiply the h in each term, nh minus h nh upon 2. Now the value of the nh is 5, so we can put the value of nh is 5 minus h into 5 upon 2. Now apply the limit 5 minus of 0 upon 2, so we can get 35 upon 2. Now these are some important questions here we discuss about the definite integral limit of sum of the part 1. Now you solve some questions for your practice. Now this question number 1, question number 2, and question number 3, and question number 4. Thank you so much.